All right. Well, happy lunchtime, everybody. Appreciate you joining us for Back to Basics, the core concepts of asphalt pavement design. Again, our instructor today is going to be Chuck Mills from the Asphalt Paving Association. Appreciate Chuck coming in to do that. This is our first Lunch and Learn webinar. So this is something we just started recently at the LTAP program. And so for those of you that are unfamiliar with the local technical assistance program, there's a LTAP center in all 50 states and one in Puerto Rico. There's also 7 tribal TTAP programs. And really our job is to kind of be a help desk for people in transportation. One of the focuses of the things that we do at LTAP is to try to get information out in the form of training, meetings like this, as well as other programs to try to help people that are working in transportation. So we're here for you. So one of the things we want to hear from you is what you need. So we'd like to hear from you at the end of the webinar today. I've got a quick survey at the end of the webinar. It's also the survey that you do to show that you were here to get the certificate of completion. So I'll put that up towards the end. But before you get to that, we do want to hear your thoughts about the webinar today. So this is a series of just introductory webinars. They're really more of a meetup, a lunch meetup. So, hopefully you brought your apple or your peanut butter and jelly sandwich or whatever you have for lunch today. And the intent is to have about 30 minutes of discussion. So I really appreciate Chuck joining today. We have a lot of people signed up for this webinar. So we think we've got a good topic. Hopefully we've got a good format too. And like I said, at the end, we'll stick on for questions and answers as long as we can twist Chuck's arm to stay on. So again, this is part of a series that we're starting. We're kind of dipping our foot in the water with this lunch and learn type format with an ongoing series. So May 29th, June 3rd, and June 10th. Again, all focusing on asphalt pavement. So again, we're focusing on that topic area for right now. We'll move to other topic areas and add other topic areas if these prove to be successful and people like them. Based on the number of people that signed up to see today, I think we'll probably be doing more of these. So with that, I want to turn it over to Chuck, give him as much time as possible. So Chuck joined the Asphalt Pavement Association in 2005. So as the Director of Engineering prior to that, Chuck's worked in industry in different areas with MITA and the Michigan Pavement Association. Chuck is a civil engineer and graduated from Michigan State University and somebody I've known for a very long time. So I'm thrilled to have him here today. Chuck, I'm going to turn it over to you for today. I'll kind of manage the chat for you. So as people have questions, go ahead and if you want to share your slide, you can go ahead. And as we have questions, I'll jump in and let you know.
Okay. Everything look good on your end there, Tim?
Looks fabulous, Chuck.
Great. Well, thank you, Tim, and thank you to Ingrid for setting these things up. I think it's a great opportunity to, give some knowledge back to people and maybe pique some people's interest, and we can delve into things a little deeper. First thing I want to talk about is, now my slide's not advancing, right? Let me see. Here we go. Today is May 15th, is a National Asphalt Day. So this is the second annual Asphalt Day. Last May 15th was the first one. So happy Asphalt Day to everybody. What we're going to cover in today's presentation, we're going to talk a little bit about composition of asphalt. What is asphalt? Talk a little bit about uses and placement. And then we're going to spend some time and focus on designing pavements. So what is asphalt? When you hear the term asphalt, what comes to mind? A road with a black surface, black top. It's known as a lot of different things. Asphalt pavements, also known as flexible pavements, consist of layers covered with asphaltic concrete layers. So for example, here you see there's granular layers, the subbase, the base, and the surface course is the asphalt mixture that we're talking about. That's that asphaltic concrete or the flexible pavement surface. Asphalt is placed in layers, which are glued together with tack coat. So we've got that asphaltic concrete, that flexible surface, but that is also broken up into different layers as well. And each layer of that asphalt pavement can be designed as a different mixture. Typically, lower layers or the base layers have larger aggregate sizes, and the surface layers have smaller aggregate sizes. Really, when we're talking about what is asphalt made up of, it's about 94% aggregates. So you got stone and sand, and about 6% asphalt cement. Now, asphalt cement is the sticky black stuff that glues everything together. It's a viscoelastic material, so when it's hot, it flows, and when it cools, it hardens, and that glues everything together. So when we're talking about the different aggregates that we use in asphalt mixtures, they need to possess certain properties. They have to be durable. They have to be resistant to environment and traffic and wear. And so all these things, we got to use specific aggregates for these mixtures to hold up under traffic and the environment, and also meet the specifications. Asphalt cements are engineered for application as well. There are different types of asphalt cements that we use for different traffic and different applications. There's other additives, recycled materials, and things that are used also in asphalt pavements. RAP, RAS, we use warm mix additives, adhesion promoters, recycling agents. There's all different kinds of additives that can be used and designed specifically into the asphalt pavements. These asphalt designs are developed by highly skilled technicians and engineers, and verified by the owners. So we got to verify that they meet the specifications. So, asphalt production plant. This is a typical asphalt production plant. You can see here around the yard all the different aggregate piles. I've got another slide here, and I'll kind of go through the whole process. So, how are asphalt mixtures produced? It starts out with the aggregates. They get loaded into the cold feed bins down here. Modern asphalt plants, sometimes they'll have 8, 10, 12 different cold feed bins. And that's so that we can mix together different types of aggregates to meet that blend that's required to meet the specifications. Those aggregates go up the main conveyor belt and into the drum. Now, the drum is where all the magic happens at the asphalt plant. There's a big heat source down at the one end of the drum, and its main function there is to dry those aggregates. So the aggregates have moisture in them from being out in the environment. The asphalt production plant, they have to test the aggregates every day to see what the moisture content is. And so by rolling through the drum, those aggregates get dried before we introduce the hot liquid asphalt to them, so that way the asphalt can stick to those rocks. Here we have the recycled cold feed bin. We add that in back further away from the flame so that, we're not going to cook that wrap. So that's added right before the liquid asphalt. So then that blends with those dried aggregates. And then the hot liquid asphalt gets mixed in after that and creates our asphalt mixture. Also at the plant, we have liquid asphalt storage tanks. We have a bag house. The bag house, think of that as like a big HEPA filter for the asphalt plant. So the asphalt, as you're drying those aggregates and they're tumbling around, we create a lot of dust in that. So the bag house collects that and cleans that air before it outlets it into the environment.
We had a quick question in the chat. Does asphalt cement contain any Portland cement percentage?
No.
No. Okay.
Not typically. There are certain types of mixtures, more like for microsurfacing treatments and things like that, that have some Portland cement in them. Yeah. But for asphalt mixtures, no.
Yeah, I think the confusion is always when you hear asphalt cement.
Right.
Are so used to hearing
or
cement.
Asphaltic concrete.
Yes.
Concrete's kind of a generic term for a hardened surface.
Yeah.
And so you either use Portland cement, which glues everything together, or the liquid asphalt.
Yeah, great question. Thanks, Chuck.
Yeah. So once the asphalt mixture comes out of the drum, there's a slat conveyor that takes the mixture up and stores it into silos. Some asphalt plants will have one silo, some will have multiple, up to 12 or 15 silos. And that's so they can store that mix in there, and they're heated. That mix can stay in there for up to like 72 hours typically. And that gives the producer opportunity to make multiple different mixes. Um, Trucks pull in under the silos to get loaded, and there's loadout scale there, so that make sure that they're getting all the right amount of mix, and everything is controlled in the control room. Modern asphalt plants are very computerized. You can put in the different mix designs, and it adjusts the cold feed bin ratios and belt speeds and all that in order to make the mixture meet specifications. Asphalt is always also very sustainable. A lot of people don't know that asphalt pavements are the most recycled product in the world. NAPA, the National Asphalt Pavement Association, they do a survey across the country every year. We just got the data from the 2022 survey, and over 98 million tons of asphalt pavement was recycled back into new mix. So that can save pavement owners nearly $5 billion in their costs. And we're seeing the asphalt recycling going up. They've been tracking this since 2009. In 2009, there were about 56 million tons of asphalt pavement recycled into new pavements, and we're up to 98 million in 2022. Each year, over 15 million tons of asphalt is produced and placed in the state of Michigan. That equals over 25,000 lane miles, or roughly the circumference of the earth. So just the asphalt we make here in Michigan, we could pave 1 lane mile all the way around the world.
Chuck, I see we've got just a couple of questions with raised hands. If you have a question, you want to type in the chat pod, we'll read them off to Chuck. So, and looks like Ryan, are you able to type your question in the chat? Okay. Looks like we've got them all caught up so far.
Okay. I'll keep moving along then.
Great. Thanks.
Next, we'll talk about uses. Asphalt pavements are very versatile. They're used for a wide variety of applications, from heavy highway traffic, airports, railroad track underlayments, heavy duty commercial, light duty parking lots. Porous asphalt has been used on paths and in parking lots. So it can be designed for a lot of different uses. They're also easy to maintain at a high level serviceability. Most people have probably seen, mill and fill projects. You can design that asphalt pavement to last for a long time and just mill off that surface course and put a new surface on it every so often and keep that pavement in good service over its life. A little bit about asphalt mix selection. As I said, there's a lot of different ways that we put mixes together, a lot of different uses, but it's really important, as designers are putting projects together, to use the right mix at the right place. For example, here I'm showing a big parking lot. You got cars basically parking on this parking lot. You wouldn't want to use a heavy duty interstate mix in this parking lot. It's not going to last. It's designed for that heavy truck traffic on it. What I like to tell people is that heavy truck traffic keeps that pavement alive. In a parking lot, you don't need all of that loading capability. You're really designing it more for environmental degradation over time. Next, we'll talk a little bit about placement. So basically, once the mix is produced at the asphalt plant, we transfer that material via trucks out to the paver. So typically in Michigan, we're using either, end dump trucks for smaller projects and the big flowboy trailers that you see out there when we're paving roads. Those flowboy trailers can haul up to 50 tons of material at a time. And there's a conveyor system at the bottom that transfers the material into the paver. The paver is responsible for placing the material at the grade and slope specified. And really the way the paver works is the screed kind of floats behind it, and that's what gives the opportunity to smooth the road as we're repaving a road. And then once we get the new asphalt mix on the road, we have to compact it. And so we're using rollers behind the paver to compact that mix. And compaction is what we call densifying that mix. So we're reorienting those stones, getting it down to the right air void amounts so that that pavement becomes impermeable. Compaction is a big key as far as long-term performance of our pavements. One of the essentials for a consistent and high quality asphalt pavement is to provide for a continuous operation. So, best case scenario, the asphalt's being produced at the mix, it's being trucked out to the project, it's being loaded into the paver, and the rollers are able to densify the material and keep that whole thing moving in a continuous movement. Anytime we have stops or breaks and things like that, it allows issues to occur. So continuous operation is key for high quality asphalt pavements.
We've got a question. How does asphalt temperature affect the final product quality?
Asphalt temperature is very important. As I said, density is key. And there's certain temperatures that every mix is compactable. So you got to be able to roll it at those certain temperatures. There's a lot of factors that go into that. The different types of liquid asphalt cement that you use, if you're using warm mix additives, things like that, those temperatures can change. So you can't always just say, well, it's got to be, 280 to 170 degrees. That's kind of a typical range of where you're getting compaction, but it kind of varies based on the liquid asphalt that you're using.
Awesome. Thanks.
Mm-hmm. So next we'll talk about pavement design. So what are the goals of pavement design? We want to design a structure that's going to withstand the effects of traffic and environment over the life of that pavement. We want to, while we're doing that, we want to minimize life cycle costs. That gives us that value and maximize user benefit. So, there's user cost involved in any pavement project. So we want to be able to maximize that as well. So this is always a good picture. Layers are necessary when we're doing a pavement design to provide economy while protecting any weak materials. If you have softer subgrades, you might have a thicker pavement section above it, or maybe there's some remediation that you can do as well. So the asphalt pavement on top is only as good as what's underneath it and the base and the structure underneath it.
Chuck, a couple more questions about mixture, if I can interrupt you a little bit.
Yeah, no problem.
So the question is, so mix design will determine the temperature. I think, again, to forward on to your point, it can, right? Depending on what you include for materials, temperatures.
Usually when
temperatures could be,
depending on what liquid asphalt you're using, there's a mixing, a maximum mixing temperature, and then there's a compaction temperature that are specified based on what PG grade binder you're using.
Yeah, here's a good one. What's the minimum ground temperature asphalt can be paved on? And there's a loaded question. Is that based on good quality or based on spec?
Yeah. I mean, by spec for like thin lifts and that, it should be 50 degrees and rising. Thicker lifts, maybe you can go down to 40 degrees. I know a lot of times you get down towards the end of the year and sometimes you're just filling in the hole depending on what you're doing. If you're building a brand new roadway, maybe that's not the best practice, but so there's a lot of factors that go into that. I mean, if the sun is out there, that can give you a little more leeway just because it keeps the mix hot longer. The problem with like a cold surface is you're putting that hot mix on it and it cools faster. giving you less time available to compact that mix. And that's the key.
Yeah, so it's a time and temperature thing, right? And
Yes.
an equipment thing, right? If you have more equipment,
You can compact
potentially.
it quicker. Yeah.
Yep, yep.
Yep.
Another question, what's the minimum temperature for asphalt to be laid down and to send it back to the plant? So again, kind of a spec versus a best practices.
Yeah.
Where do you
And
get concerned?
that's dependent on the mix too. I mean, if we're using some warm mix technologies and mix shows up at, 220 degrees, that's just fine. If it's a mix that should show up at, 290 minimum, then you got to reject that load. And that's why we have those specifications. And then it's usually based on the recommended temperatures. So it's a variation from that. So it's not just one number all the time. Now, if you're using the same mix all the time, then you know what that number is, and you can kind of go by that.
Something in the pre-production meeting where you should talk about that with contractors as well. Correct?
Definitely. Yeah.
Yeah. Yeah. Another question, how important is it for a full tack coat full tack coat between HMA layers?
Oh, tack coat's very important because, as I said, we design that pavement section to be, say, 8 inches thick, and we're putting it in 3 lifts. Those 3 layers have to be stuck together to work as one layer.
Otherwise you get
Structurally.
slippage,
So,
right?
yep, you can get slippage issues, cracking issues, different things with if you don't get good tack coat coverage. And when we talk about tack coat, we talk about the coverage. Most of the times when issues do arise, there's equipment problems or whatever, you see little streaks of tack coat being put down. I mean, you want a good even coat coverage, and to make sure that you've got that tack where it's supposed to be.
Yeah, those nozzles never plug ever.
Yeah. Yeah.
All right.
That tack
Good.
material has to stay hot too, so that it can be sprayed and all that. There's a lot of opportunity for issues, definitely. So you got to keep on top of it.
Okay, I think that's all the questions. We had a flurry of temperatures questions, so.
Yeah. Um, okay, so we were talking about how flexible pavements work. Basically, we want to provide sufficient total pavement thickness above any material that's where, that base material to prevent permanent deformation. So, in the picture on the right there, the surface, which is your asphalt pavement, and the base and subbase have to be sufficient thickness and give enough support for the loading conditions so that we're not um, deforming that subgrade underneath. And then we also want to provide enough surface thickness to prevent fatigue cracking. So, over time with traffic and that, you don't want the pavement to crack up. So we look at using a layered approach to distribute the load over the weaker materials. So how do we design pavements? There's lots of different design methods out there: empirical, limiting shear failure, limiting deflection, regression based on road tests, and mechanistic empirical methods. Those last two, regression based on road tests, that's the AASHTO road test, which we'll talk a lot about. That's probably the most common way that people use for pavement design. Mechanistic empirical methods, more state agencies are getting into that. The Michigan Department of Transportation is using that now, but they still use the AASHTO as kind of a check. So we'll talk a little more in detail about the AASHTO. So the road test regression methods, we're using regression techniques to develop performance prediction equations, basically. And like I said, the AASHTO 93 design pavement structures is kind of the guide here. And we start with a resilient modulus of the subgrade, and then what are the moduluses of the different materials that we're using to protect that subgrade. We look at what is our design reliability, those factors, based on the facility that we're designing. We also have to take drainage into consideration. If we're using materials that, don't drain as well, there's drainage factors that you put into those. Environmental factors such as frost heave, swelling soils, thaw weakening, and all those things can all be accounted for here. For any of the engineers out there that had a pavement design class, you know this picture here, the AASHTO nomograph. Before computerized programs were put together, this is how we came up with our design structural numbers, and then came up with our pavement design from there. Um, I remember having copies, blank copies of this that I could use to come up with pavement designs. But basically, we're the astro design is based on determining the structural number above each layer, um, and then finding that thickness that'll provide that structural number to protect the layer below it. Luckily, there is a simple solution for doing an AASHTO design, and there's a great tool out there. It's called Pave Express. It's an application, so you can do it on your phone, you can do it on a tablet or on your computer. Um, it's at paveexpressdesign.com. It's a free app. All you got to do is to log in is give them your email, and you'll have an account, and you can save your designs. I'll kind of go through some of the highlights of how Pave Express works. So this is the home page for the Pave Express, and you can log in, you can set it up. There's a lot of different modules in here. You can do a brand new pavement design. You can do a overlay pavement design. You can do a concrete pavement design in here. There's life cycle modules where you can, look at the life cycle cost analysis of multiple different designs. And there's a lot of good reference information included in here. It's tied in with another website called Pavement Interactive. A lot of good information in there. So when you start a design, you start out with, what are your scenario? What do you want to call your design? This is a typical page here where you're just starting out. And then you next step into your design parameters. You look at what is your design period, reliability level, your standard error, all those things that, go into an AASHTO design, your initial and terminal serviceability, and you put all that in. Next thing you do is you put in your traffic and loading. If you know your design easels, you can go right to that. You can calculate from your average annual daily traffic. That's probably the most widely used one. Or if you have annual easels for your road, you can put that in as well. So next, you go into the pavement structure, and you can go into looking at adding layers, different. You start out with subgrade modulus. There's different ways of calculating it. If you know the CBR or R value, you can put in your soil type. If you know your resilient modulus, you can just put that in. Then you can add in different layers. So if we typically use, 6 inches of ag base over 18 inches of sand sub base, you can put that in here. And then it will calculate. By now, you've got all your layers in there, you got your traffic in there, and it's going to calculate a design. So for like this one here, we got 9.5 inches of asphalt over 6 inches of ag sub base and 18 inches of sand sub base. So that's kind of a quick overview of Pave Express. There's a lot of different training webinars out there. I've done a few of them over the years. We could spend an hour kind of going through all the little details, but just to kind of give you an idea, it's something simple, and it gives you that AASHTO pavement design. So when we're thinking about pavement design, what are we doing? We're really designing for the public. So we want to, give them the best value for the money that they're spending. Regardless of the method that we use to design our pavements, we need to know traffic levels. We need to know our environment, freeze thaw cycles, temperatures, rain, all that kind of stuff. We need to know what materials are available. If we can design our asphalt materials and our base materials using locally available materials, that goes into our value and our cost. And we need to know variability. You know, what's our standard error or reliability factors that we want to look at to make sure that that pavement structure that we're designing is going to last over the intended service life. So with that, is there any other questions?
We do have a couple of questions, Chuck. So one of the questions is about recycling. So can asphalt cement be recycled indefinitely, or is it always necessary to add a rejuvenator? So can you maybe talk about what happens with asphalt cement as it starts to age?
Yeah. And there's been a lot of studies over the years with, how that happens. And the way a lot of specifications for using wrap are set up is, it accounts for that. As we get into using more wrap in the mix, we put more virgin asphalt in there because we're accounting for that wrap binder to be more stiff and aged. So we still want to meet the specification. There are also some rejuvenators, and looking at how that affects that old aged asphalt binder and does it give us more of a blending between that and the new asphalt binder. There are some studies that are suggesting that, maybe we look at doing like a percentage of what we get out of there. So there's a lot of testing and research that goes into that. A lot of the wrap that's being used is size. So we're crushing it and making different sizes. The coarser wrap probably has a lot less asphalt that it's putting into the mix. And then the finer wrap stuff probably has more asphalt in it. The finer aggregates have more asphalt on them. So it is a highly tested material. We tested every 1,000 tons to find out what that asphalt content is and, the gradation and all that so that we can incorporate that into the new mixes.
The assumptions is that the recycling, if it's being milled and taken up, it's relatively, there's an age limit, right? It can't be 100-year-old asphalt probably. So
Yeah, because there's going to be less
still
asphalt left in that. You'll see that in your testing. Yeah. There's going to be a lot less asphalt in there.
Hey, we got a whole bunch of questions. So we got a bunch of questions about the recording. So we're doing a recording. We'll send the link out after the class along with your certificates of completion. And Chuck, if you don't mind, if we could get a PDF of your slides, that would be great.
Yep. We will send that out.
Okay. And let's see. Would you explain how why concrete is used for freeways and asphalt used for parking lots? You said that trucks keep concrete alive on freeways. Can you
the trucks keep the asphalt. Yeah, there's a lot to that one. Concrete isn't just used on freeways. We've actually, over the last few years, MDOT has been rebuilding a lot of their concrete freeways with asphalt. And we here at the Pavement Association feel that, that's due to because we've been modifying our mixes and focusing on quality and we're catching up that way. We actually, in MDOT's life cycle cost analysis process, we last longer than concrete pavements.
And that's maybe to give some background to that question too. So a lot of the times when there's a decision between asphalt and concrete, it does come to like what Chuck said, life cycle cost analysis. So freeways, it can be beneficial if the user costs for, say, preventive maintenance, where you have intermediate preventive maintenance activities. Those user costs can get very high. And so that can shift, if you want a pavement that maybe you don't have to touch less frequently or more frequently. So it's trade-offs, just like any other material decision. But usually it comes down to life cycle costs. That's how the decision is made.
Yeah.
Is there a newer version of the AASHTO guide for design of pavement structures other than the 93, or is it 93 or 91 method?
It's the 93 method used for the asphalt, and I think it's the 98 for concrete.
Yeah,
was the last update on that one, and there is not. And a lot of the reason this Pave Express application got put together is there used to be a computer program that people could purchase. It was called Darwin that did an AASHTO pavement design. And that was kind of going away. They weren't supporting it anymore, and you couldn't renew that. So we saw a need out there, um, and that kind of got put together that way so that people could still do that. Because a lot of the states are moving, like I said, to the mechanistic empirical format, and that's a very expensive program. It's also a lot of research they have to do because you have to calibrate it to your local materials and asphalts and concrete and everything that you're using in there, so that it's kind of a more of a engineering approach to it rather than an empirical, based on the road test. Some people have questioned, how can we be designing pavements when, the Astor road test was done back in the early 60s, late 50s, and trucks are different, traffic's different, all this stuff. And we're kind of, you know, regressing way past anything they ever did there. Um, but I will say, I mean, a lot of people's opinion is that, well, we've been doing it for a lot of years and we haven't had any like big problems with what we came up with. I think there's enough factors of safety in there and things that, engineers put in, and we're they the state seems to be happy with that. They're happy with how their performance is showing using that, and that's why like MDOT still uses that as kind of a starting point, and then they'll run the ME, and as long as it's within plus or minus an inch of what ASHTO was, then they'll use that.
Another question, is MDOT considering recycled tires in HMA? I know there's research going on in that area.
Yeah, there's a lot of research going on in that area. There's been a lot of grant projects that Eagle has done. MDOT hasn't done a whole lot. They did one or two pilot projects, I think. But yeah, that there's a lot of research. I know there's been over the years, there's been a lot of different processes. There's wet process, dry process. There's
Yeah.
and I think there's still, a lot of stuff going on there.
Yeah, just like any new material that it's a slow process for testing it, doing research, testing it, and seeing what the result is. There are a fair number of projects going on in local agency projects. Dr. Jean-Ping Yu at Michigan Tech has done a lot of work, as well as there's another gentleman at Michigan State, and his name escapes me.
Yeah, Dr. Kute.
Yes.
Yep.
Yes,
Yeah.
yes.
Yep. Yeah, and there's a lot of out there on the road, and everyone's watching it and to see if it's going to take hold.
Yeah,
Like
I want to say
you said,
there's
any kind of new materials, it does take time, just because engineers are very cautious people. We want to make sure something works before we just put it everywhere, right?
nobody wants to be the first failure. Yeah, I think there's something like 70, is that right? 70 projects, Chuck, that you know of?
I think there is, yeah, something like that. Yep.
Yep.
And I know now they're putting it in chip seals and different,
Yep.
they're trying all kinds of different applications.
Kalamazoo County has tried rubber in chip seals. So, yeah. As well as I think Bay County is another one. Is there any benefit to fiber products for increasing asphalt mix strength and longevity? Does it reduce flexibility of the pavement? So I know there's Armid fibers that people have been using.
Yeah, there's a few different types of fibers. And I think they're, again, they're doing pilot projects on them. Some of the thought is, it increases the strength of that layer. So maybe that structural coefficient is a little higher. We can thin up maybe some of our pavements. Some people are using it more to try to resist reflective cracking, different things, it has some uses with that. And like anything, that we're adding into the mixtures or doing something different, you got to look at the cost benefit ratio of it. And but I think some of that stuff is showing some promise in some areas, especially as we face funding issues and we don't have enough funds to really maintain the roads the way we should. People are looking for ways to kind of prolong that life, and have less maintenance to do down the line if we can resist that reflective cracking and having to go out and crack fill or mill and resurface more often, different things like that, putting surface seals on. And yeah.
Can you talk a little bit about warm mix asphalt? So how common is it? What are the benefits? Maybe just talk in general about the difference
Yeah.
between warm mix. What is it? How is it different?
Yeah. What warm mix is it allows the mix to be made at a lower temperature. So if you have warm mix additives in that, it blends with the liquid asphalt and reduces that compactable range temperature, the mixing temperature, and all that. So what the idea there is we can burn less fuel at the asphalt plant. We can be more efficient. I think you'll see more of that happening here in the future. The asphalt industry has a goal of by 2050 to be carbon neutral. You know, so everyone looking at environmental issues and ways to reduce carbon footprint and all that. I think warm mix is going to be a big key.
And
It
so,
gets used here in Michigan. It can be used for reducing those temperatures. It can be used for increasing haul distances, because that mix is cooler, and then it's not going to cool off as fast. Gives you that bigger compaction, time available for compaction as well.
and Chuck, there's a couple of different materials, right? There's a wax type material, and then was it foamed asphalt? Is that the other one?
Yeah, there's even more than that. I mean,
Yeah.
there's different chemical ways of doing it, and then you have the foam asphalt. So there you're introducing water into the liquid asphalt to kind of foam it. Um, some people are doing that just as a compaction aid. They're not really reducing temperature a whole lot, but it makes the mix more workable, more compactable.
Yeah.
Uh,
So same concept with concrete, right? With add-mixtures in concrete, it's going to
yeah,
change physical properties and the workability properties of it. Yeah.
yeah, yeah.
Is there a way to change the mixture subgrade to stop those skidding bumps seen at intersections from semis? So that would be the shoving, bumps where you have stop and go activity.
Oh yeah. Um, I think that's a lot that goes into that is your pavement design for one, and then your mixture selection. Um, and then making sure you got a good tack coat, all those things kind of play together. Um,
So
but
mixture selection, if we had a finer mix, which might be smoother with smaller aggregates, right?
yeah,
That's gonna,
well, and you want a tougher mix as well too. So maybe a higher volume mix of polymer modified asphalts. There's a lot of different things you can do there as well. Um, you got to look at what is the cause. Is it doing that where we did an overlay? Is it just in that top layer, or is it a base issue where the base is moving and then that's causing the tires to move and then deforming the asphalt that way? Um,
yeah,
yeah,
a little bit of troubleshooting, right? So it could be
yeah.
tack,
It's a
right? Or poor tack, could be.
it's like most problems that you see out there. It's like, okay, what's the root cause of it? We can't just say it's just this all the time. It's you got to look into what's actually causing it.
Yeah. Uh, is it a good trade-off to swap the traditional 8-inch stone, 2-inch binder, and 1.5-inch surface design with a 7-inch asphalt, 7-inch thick asphalt layer on residential roads? So I think this is the question of trading off layers. I think I know what you're going to say, Chuck. 7 inches of asphalt is much better. So the question is, talk about the layers. There's a
Yeah,
trade-off layers.
there's a trade-off, and that's where when I was talking about the pavement design, you want to design the most economical pavement cross section that you can, obviously. Um, and there's a lot of things that go into that. How much room do you have? What are the soils like underneath? There were, back in the past, there were, swapping out that aggregate and just putting in 7 inches of asphalt and called that a full depth asphalt section. Um, you know, and that can work in certain situations if the subgrade is pretty good. And then maybe that buys you a longer period of time. or if I just go in and periodically mill and resurface the top, um, you might not get those fatigue cracks or those block cracking that you get after 30 years and you haven't done anything to the road. And those types of things with the thinner, sections. But
Is
it really comes down to economics.
is it fair to say, Chuck, that the pavements have gone with thinner asphalt and thicker overall section over time? Is that true?
MDOT's the one that you can kind of look at, and these are their typical pavement sections, and they've been the same for the last 30, 40 years.
Okay.
So I don't think that we're really thinning up pavement sections a whole lot.
Okay.
In some instances where we talk about perpetual pavements, we may design them a little bit thicker, so that then we never have to go in and dig everything out. We just mill and resurface the top course.
Yeah.
Yeah.
Another question, how much does centerline rumble strips, I think that's what we're referring to, shorten the pavement joint life? I know there was a study done by, was it Pete Salvalainen and Tim Gates from Michigan State, I think did that.
Yeah. Yeah. And just talking kind of what I've seen, that was a real concern when we first started doing them. And I've been around long enough that I remember when we had those discussions and we thought, all the asphalt experts were, why are we doing this right at the joint? That's, the weakest point in the pavement. Now we're going to set water there. We haven't seen a whole lot of really bad deterioration because of it. We had the issue with our mixes for a while there that were very dry, the first super paved mixes, until we've gotten to where we're racing the mixes and getting more liquid asphalt into them. We had some joint problems there. Now we got a longitudinal joint specification and we've regressed the mixes. And I think we're seeing a lot better performance for that. But the rumble strips, I was really concerned about those, especially with thinner overlays. And then we're overlaying over those rumble strips. You got a thin overlay and then you're regrinding them. In some areas, you might not have much mix at all left there. And I thought, that might peel right off, but they've been performing pretty good overall, I would say. We haven't seen any catastrophes like we worried about.
There's been more of a focus on joint quality too, right? Joint compaction.
Yes.
So you don't see the old joints that have opened up and there's, you could throw a cat out between the joint.
Yeah, and you see that little 2-foot mill section that we, to kind of replace the mix that's just, raveled away basically. And that was, a couple different issues. It was it's hard to get density on that unconfined edge. And then we had dry mixes that, ravel anyway. So low density, they ravel even faster. And that's how that continues to open up.
Yeah. Another question, I think this might be our last question that I've got up here. So how does asphalt and Portland cement work to create a semi-rigid pavement?
A semi-rigid pavement. Well, I guess I would say if anytime you have cement, it's going to be rigid. There's composite pavements, but I still consider them rigid because if there's concrete there, it's going to be rigid.
Yeah.
And in composite pavements, the big problem is as the concrete moves, you get all the joints cracking up through the asphalt.
I guess that one, Portland cement is a chemical set, right? So it's a chemical process where asphalt cement is, what would you say that is? It's not really a chemical set. It's
more of a physical set.
Phase change, right?
Yeah, phase change because it's going from a liquid to a solid. And even then it's not, it's solid, but it's not completely solid.
Right.
You take a tin of asphalt cement and push your finger on it, you can't indent it. But if you kept your finger there with pressure, it'll go down eventually.
Yeah, it's a flowable solid, right?
Yeah, exactly. It's flexible.
Yeah. Where Portland cement would be chemical set, so the material is actually changing chemistry. Right?
Yeah, the water added to it, and then hydration happens, and it hardens.
Yeah.
So I don't know about a semi. Yeah, that's semi flexible.
Okay, Chuck, I think we have all the questions answered. That was a great,
Well, that
great
was pretty
list
good.
of questions. Yeah, and appreciate you sticking on for a
I
little bit
just
more.
had a last slide here again to kind of show the asphalt series, the upcoming dates here too. So, um, and I had my email address on there for anybody that does have any kind of questions or anything, but I guess I can stop sharing here.
Yeah. Looks like we got one more question. Your
Okay.
opinion on pervious asphalt in Michigan's climate?
It's actually worked out pretty well. There are quite a few examples that are still in service 20 years now and more. Actually, I think the Rouge plant was done in 2000, and I'm pretty sure I haven't been out there in a while, but I know there's some in Washtenaw Community College that were done in 2004, 5 era, and they're still working good. Some of them, we had some issues with maintenance, um, uh, but I think it can work, and it's a great solution for water management, stormwater management. Yeah, I kind of laughed when we were first doing them. It kind of shows how um, cautious engineers are. We'd put porous asphalt in the parking lot, and we are still putting curb cuts and everything to make sure that water is going to drain off, and so it could still get down to the retention pond.
Belt
And
and suspenders kind of approach, right?
exactly. Um, there was it was funny a few years back. I was doing a presentation about porous asphalt, and I was doing some research, and I found there was a guy who did a presentation about what if we could make asphalt that didn't crack. And he was showing slides from the Washtenaw Community College parking lot. So when they did that, they did kind of the lower half of it with porous asphalt, and the upper half they just repaved with that regular asphalt. And 15 years later, that regular asphalt was starting to develop a lot of cracking, but those cracks stopped when it got to the porous asphalt section, which kind of makes sense because it dissipates that crack energy. It's highly polymerized liquid to have that 20% air void so water can flow through it. Um, and MDOT uses what we call an asphalt stabilized crack relief layer, which is basically a porous asphalt over concrete to kind of mitigate that cracking coming up.
So the idea is with that crack relief layers to spread the stress over a larger and larger area, right?
Yep. Yeah. Kind of dissipate it out so that it's not a point stress on
Yeah.
that asphalt overlay.
Well, it looks like we got a couple more questions, if you don't mind.
I don't mind.
Okay. So what geogrid membrane materials could be recommended for placement under asphalt layer and on top of a base layer? So under a layer, so we would be talking about between asphalt and the base aggregate layer.
Hmm. Well, I mean, it obviously depends on the situation and what type of grid material you're using. I mean, I'm not a geotechnical engineer, but basic pavement design is what you're trying to do. You're trying to stiffen up that base area there probably so that there's less flexure and cracking happening in the asphalt layers.
So normally it would be lower in the pavement layers, in the aggregate layers, either the
So are
sand.
they talking were they asking between the layers of asphalt?
Um, let's see. It actually says placement under the asphalt layer and on top of the base layer. So that reminds me of the old paving fabrics
Yeah.
from years and back. I don't know if that's even a practice anymore, is it? Paving fabrics between layers.
Not a lot. I mean, people still try them every once in a while.
Yeah.
But
So the
I
idea
don't
that
know. I get asked about them all the time, and I always say, well, if there's no silver bullet out there that someone found that worked so well that everyone's using it.
yeah, I mean, just my 2 cents. I think the geofabrics that are being used are primarily down lower in the pavements. So in the aggregate layers to add strength to those layers or act as a separator to keep the fine materials out of, say, a drainage layer.
Yeah.
But I don't know that a lot of people are still doing the interstitial layers between pavements other than crack relief layers, right?
Yeah. Yeah. Usually on an overlay or something on a composite pavement, they'll still put them down with where they, put down an emulsion, lay that down, spray over it, and then pave on it. Yeah.
Yep. Let's see. As asphalt looks to become more carbon neutral outside of warm mix recycling, are there other ways to be more efficient? What are you guys looking at to become carbon neutral?
Warm mix, EPDs,
What's an EPB?
EPD is an environmental product declaration.
Ah, okay.
So it's basically like a nutrition label for your mix design. And it shows that you get a global warming potential number off of that. So we're looking at ways of kind of tracking that. Some states have started the federal highways has a program now with some grant money available for states to start looking into developing EPDs and kind of coming up with specifications to hopefully, okay, here's kind of where we are. How can we get a little better? And ways that we can get better are, a lot of warm mix technologies. If we can lower that burner temperature, produce mixes at a lower temperature, use less fuel that way, and more recycle, different things like that. Because when you look at, you know, being carbon neutral, it goes from everything, your aggregates, getting your liquid asphalt, getting all the materials to the plant that you need, and then the process of making that and then trucking it out. There's a lot to that, and a lot of research going on. And we always talk about a lot of it's focusing kind of on cradle to gate right now, so up to the point where the asphalt's produced. And to really get into a whole life cycle assessment, you got to look at, the construction, the use phase, the maintenance, and the whole life cycle of that pavement itself.
Yeah, I never really thought about that. It is more than just what happens on the grade. That's the part I'm
Yes.
interested in.
Yes. It's how do you source all these materials and where are they
Where are they coming from? Yeah.
You're burning fuel for that. And, yeah. And, if we get to where we're using more electric vehicles, all those things that can
Yeah.
all factor into that.
So any thoughts about using an ASCRL layer between a top course and a base course to prevent thermal cracking from propagating into the base? So using a crack relief layer between the two courses.
Oh, like if we're overlaying an existing pavement.
The Texas Center seals would be one for an overlay, right?
Yeah. Yeah. I think, that could possibly if you've got thermal cracking in your pavement already that you're overlaying. Thermal cracking is more of a horizontal movement. It's from the pavement shrinking and then tearing itself apart basically at intervals. Where most of the crack relief layers, we put in those over where you got some vertical displacement happening, like panels of concrete pavement and things like that. It could probably help dissipate the energy. I just don't know how much of that thermal cracking is actually going to be reflecting through if the base is solid. But if it is acting where you've got some vertical movement, it could have possibly an application there. One of the things I get asked about Asphalt a lot because MDOT's been very happy with it on overlaying their concrete pavements and that. But like for local roads and things, we'd have to kind of do a thinner application of it because usually we're putting 3.5 inches of that and then 3.5, 5 inches of asphalt over that on a concrete pavement. And where if you're in town or something, you got curb and gutter, it's hard to do all that kind of stuff.
Yeah, but I mean, a crack relief layer between two new layers of
Between
asphalt doesn't really make sense, right? Because they're the same
Right.
material. So where you'd have an older asphalt that maybe is more brittle and is not going to shrink and expand, right? That would be the
Yeah.
area where there's a different potential between those two materials.
Right. Yeah. Could have an application there.
Yeah. Well, awesome. Thank you so much, Chuck. I appreciate you overcoming the adversity today with Chuck's power went out today, as did mine, bumped today. So we thought, oh boy, we've got all these people signed up today. So I appreciate you taking the extra effort to
Oh, no problem.
with power today.
Luckily, I was able to run home quickly and
All right. I'm going to go ahead and put the evaluation here in the chat pod. I should have actually probably done that a little bit earlier because a couple of people had to jump off. And we'll stick on for just a little bit while people fill this out. And so thank you very much for everybody for joining. Chuck, appreciate having you today. So again, the SurveyMonkey link is in the chat pod. I'll keep putting that in there. So if you can fill that out, that's how we want to hear from you about the class. What are the topics you'd like to see, as well as the certification survey to fill out to get your certificate of completion today. So thank you very much, Chuck. I appreciate it. It's good to see you.
Thank you, Tim. Good to see everybody here too.
Okay. Awesome. Just a reminder, there's a link in the survey, or the link in the chat pod for filling out your evaluation today. Please take the time to fill that out to get credit for today's class, to get a certificate of completion. We will also be sending out the PDF of the slides today, as well as a link to the recording. Thanks very much for joining us. We'll stick on for just a little bit longer for you to get that survey link.